In order to solve the problem of composite slab, I have opened Ansys Workbench. In the Ansys Workbench, I am going to take the steady state thermal and drag it and drop it on the project schematic. Once I place it on the project schematic, I am going to double click on the engineering data and I am going to add 4 materials, namely A, and then B, then C, then C and D. I have created 4 materials. For those 4 materials, I am going to take this isotropic thermal conductivity and give that particular property to this 4 materials. So once I give this particular property to 4 materials, I need to enter the value. The value of the thermal conductivity we were given in watts per meter Kelvin, and here it is watts per meter centigrade. We need to change it to watts per meter Kelvin, then enter the value. For this D material, it is 0.04. Then coming to C material, I need to change the unit again, and the value is 1.7. And then coming to B material, the value is 0.12. Coming to A material, the value is somewhere around 0.038. So once I have given the required thermal conductivities, I am going to close this engineering data. And right now I am going to just right click on the geometry, say import geometry and browse, and I am going to select this composite slab and I am going to press OK. So now I am going to double click on the model cell in order to open Ansys Mechanical to apply the required temperature loads and solve this particular problem. So once the Ansys Mechanical opens, what I am going to do is I am going to expand this geometry group and I am going to select this object and I am going to give the material A. Then I am going to select this slab and I am going to give the material C. And then I am going to select this slab, I am going to give the material of D. And I am going to select this slab, I am going to material A. Sorry, it is B. As per the problem specification, we have given this particular block is made up of material A, this is B, this is C and this is D. In that particular order, I have assigned the materials. Once I have completed assigning materials, my next option is I need to right click and say insert and go to temperature. As I have already told you that temperature, convection, radiation, heat flow, perfectly insulated, heat flux and internal heat generation are the type of boundary conditions that are available with steady state thermal analysis. In this particular problem, we are going to take the temperature and we are going to apply the temperature to this particular phase. I am going to apply, and the temperature at this particular phase is 80 degrees. So I have given 80 degrees. Then coming to this particular phase, the temperature is 25 degrees. So I am going to right click, insert, say temperature, and I am going to insert 25 degrees of temperature. And once I have given the required temperatures, then what can I do is I will right click and say solve, because what happens, these two temperatures are only the boundary conditions for this specific problem. So once I have solved the particular problem, right now what I am going to do is I am going to select insert and go to thermal. I am going to click the temperature and I am going to right click and say evaluate results. Now you see this is the distribution of the temperature inside this particular composite slab. You can even animate this particular results. See here, you can just play and animate how the temperature is being distributed inside this particular composite slab. Right now the next option or the next result we need is what is the heat flux that is generated at this particular area. So what I am going to do is I am going to right click, say insert, go to thermal, go to total heat flux, and in the total heat flux also I am going to select only this particular phase. So for that purpose I am going to go to the geometry and then select this particular phase and say apply. And once I apply the total heat flux result, I am going to right click, say evaluate all results. Once I say evaluate all results, I am going to get the heat flux that is generated at this particular phase. So this is the heat flux that is generated at this particular phase. So this is how we can solve a problem of a composite slab and find out the temperature distribution inside a body, or otherwise we can also find out the heat flux generated at a particular area using Ansys Workbench by performing steady state thermal analysis. Here in this particular problem, the mode of heat transfer was conduction, because what happens, there was a physical contact between the blocks of different materials and heat was transferring through the physical contact or molecular contact, which can be known as a conduction. In the next lecture, I am going to teach you how we can use convection boundary conditions and simulate the heat transfer through convection conditions using Ansys Workbench. Thank you.